All right, all right. Um, Waiting to go live everywhere. Welcome back to my live stream. I'm doing another coding challenge tonight called Longest Substring Without Repeating Characters. I want to give it a second to connect to all my social channels, but I appreciate everybody joining so far. Yeah, we're gonna get into it pretty soon here, probably like 5 to 10 more seconds. I'm gonna jump right into it. Uh, yeah, it looks like we're connected everywhere. So thanks everybody for joining. Tonight we're doing another coding challenge. It's called Longest Substring Without Repeating Characters. This is a medium problem actually on Leetcode.com. It's a popular problem with Amazon, Bloomberg, and Microsoft. And without further ado, we're going to jump right into it. The problem goes as such. Given a string S, find the length of the longest substring without repeating characters. So given a string S, find the length of the longest substring without repeating characters. So they give an example here, ABC, AB, CBB, and the output is 3 because the answer is A, B, and C with the length of 3. So you're trying to find the length of the longest substring that doesn't repeat characters. And in this case, it's A, B, and C. And then in this case, since all of these are B, the output is 1 because the length of the longest substring without a repeating character is B. It's just 1 because all of these are B. And these repeat, of course, because they're all B. And then in this example, WKE is the longest substring because here, this substring has 2 W's, so the longest substring is PW. This one repeats. This one actually is the longest one without repeating characters because this one would be repeating characters as well with W and W. So hopefully that makes sense. Let me know if you have any questions about that. And then there's some constraints here. You probably, in an interview, you might have to ask for these. But I mean, of course, in real life, you would need to know what these are based on the scenario that you're trying to program against. But the length of the string we're looking at is greater than 0, of course, and it's less than 5 times 10 to the 4th power. That's an interesting one they have on here. Why is it 5 times 10 to the 4th power? I don't know. Look at why they did that. And then S consists of English letters, digits, symbols, and spaces, which probably won't affect the problem too much. So anyway, yeah. So if you ever seen these before, how I like to do these is think through the solution in my mind first, maybe with pen and paper, maybe with typing something out. But I like to think through the problem first, figure out how I would solve it in my mind or logically, and then try to convert that solution to code using data structures and algorithms that I'm familiar with. And so when I look at this problem, I'm trying to basically find the longest substring in here that doesn't repeat again. And so the first thing that comes to mind, like how I would go through this list, is of course a loop. I would need to loop through this list at least one time. I have to check everything in here to find which is the longest substring. And so the first thing that comes to mind, if I'm just thinking from like the most simple way of trying to solve this problem, is simply checking every single substring in this string and figuring out which one is the longest. Basically storing which substring is the longest that doesn't have repeating characters. So how could I do something like that? Well, I could loop through this string and basically check A. I could check AB. I could check ABC. I could check ABA, ABCA. I could check all the substrings that could start with B. Check the substrings there, ABC, and BCA, BCAB. I could just basically loop through this and check every single possible substring there is in here until I get all the way to just BB and B. And then I could store whether or not I can store the longest substring that I find that doesn't have repeating characters. So as I check each substring, I can check if it has repeating characters or not. If it doesn't, then I can store it. I can say, is this the longest one I have ever seen or not? If yes, then store that value. If not, then keep going. So this is what's called a brute force solution. This is not the best solution. So some people have also commented that already or commented a different solution. But if you're just learning how to do these kind of problems, you may not intuitively figure out another solution better than this. So doing this brute force solution is better than doing nothing, especially if you're in an interview setting. And even if you're not in an interview setting, sometimes you can do a less optimal solution to help you get to the most optimal solution. So I'm not going to fully code out the less optimal solution, but I do want to kind of show you guys what it looks like, because it does build into the more optimal solution later on. So basically what I was saying to do, and I have anybody that's joined, I have the problem statement up here at the top again. But what I was thinking to do is to basically loop through my input, my string, and check every substring to check if it has repeating characters in it or not. And if it doesn't, then I need to store the longest non-repeating character substring that I've ever seen. So how can I do that? So I can definitely have a variable to say max, I don't know. Let me see. Yeah, longest. Got to name it something different than my actual function. Longest substring length or something like that. This is going to be like my answer at the end. And I know I'll eventually return that. So to be quick, I'm going to copy this out. And then what can I do from here? Well, I know I need to loop through my input. So I can basically say I equals 0. I is less than s dot length. And I plus plus. I know I need to loop through once, and I know I need to loop through again with a different iterator. So I'm going to use J for this iterator because I can't use the same iterator as the outer loop. And why am I looping through twice? So as I said before, I need to check for a substring of every single substring in this string. So I need to have a start of my substring and have an end of it. So you say I want to check ABC. I need to have a start index at 0 and I need to have a end index at 2 because this is a 0-based index. So to do that, a trick you can use is like a nested loop with pointers I and J, so that you know where your start and end are. So in this instance, I is the start, J is the end. I actually probably could just name these like start and end to be more clear. Start, end. And actually, so since this is the end, actually the end has to be start plus 1. So that's a mistake I made there. So I want to basically look at a substring of my string. So I need to have a start pointer and an end pointer. So let's say if I'm on A and B, let's say the first time I go through this, my start pointer will be 0, which is A, and my end pointer would be my start pointer plus 1, which is B. So I would look at this substring first. And actually, I need to actually look at, this is a valid substring. It's just the same letter, actually. So I need to actually check for that first, too. So anyway, so I have my start and end pointer. And this basically what this will give me is every start and end substring within the string. And so after I have that, then what I can do, what I say here, I was going to do, I'm going to basically check I'm going to make a separate function is non-repeating characters, or let's say has I don't know, what's a good way to say non-repeating characters? I don't know. I'm just gonna say is non-repeating character string. And so I'm gonna have a start. I'm gonna pass my start into it. I'm gonna pass my end into it. And I'm gonna pass the string itself into it as well. And then if it is true, then basically I want to update my longest substring length. And I want to find, I think, math max in JavaScript. So what this will do will basically say n minus start. So this is the length of the current string that I'm on, because this is the window that I'm looking at, start and end. And I want to see if this is longer than what I currently have. And I'm sorry that's dropping down a line. It's because I don't have a lot of space to show this on social media. But basically what math max does is it says make this equal to whichever is the max, whichever is higher. Is the new length higher, or is the old one I have higher? So this will make sure I always get the longest substring length. So when I return it here, I'll have the longest answer, which is the best answer. And so now I actually need to code out this function. And what's crazy about this, man, is like this brute force solution is like actually taking me longer to do than the actual best solution, I think. So it's kind of interesting, but I want to show this, man, because like we could just go straight to the end, or to like the best solution, but like I think it's valuable to see. Yeah, I do plan to optimize at the end for whoever asked, but I think it's valuable to see all the steps that it goes into of how to do things the least optimal way, the best way, so that if you do get caught in these traps, you have a way to go that will help you get to the most optimal solution and understand why the solution is more optimal than the first solution, instead of just trying to memorize the best answer all the time. And I think that's a trap that people get stuck in. They're just trying to memorize a bunch of answers and they don't really understand, the different ways of solving a problem and why certain things are less optimal than others. But I digress. I'm going to get back into the problem here now. So what I need to do here is basically I need to check this string based at this start index and this end index. I need to check is there no repeating characters. I'm basically returning true or false. So I'm going to return true at the end. But I need to basically check the substring. And shoot, this is a substring. So I'm going to actually say substring to be more clear. And then I'll change it up here too. So how can I do this though? So I need to store, and let's call it scene. I'm going to make a new JavaScript map. I need to store what I've seen in this substring. And if I see it again, then that means there's a repeating character, and this should be false. It is not a non-repeating character string. So what I can do again is I'm just going to copy this in here for the sake of time. And I'm going to make this I at this point, because why not? And I need to go through the whole string again. And so wait a minute, I need to look through start to end. So I need to start at start. So I should start at start and it should end at end. And so this would be I is less than or equal to end. So I'm looping through my string S with start and from index start to index end. And that's how you can do this with a loop. So then I want to say if scene, dang, is it has? Yeah, I think it's has. If scene has the current character that I'm on, then I can go ahead and return false, because that means there's a repeating character and this is not a non-repeating character substring. I know that's kind of weird to say. And if not, if I get to this point, then I can go ahead and, damn, is it add or is it, shoot, I forgot what the map, dang it, is it add or is it set? I think it's set. Yeah, I think it's set. So I'm going to set the map with this, and I'm just going to set it equal to true. I guess it doesn't matter what I put here, because as long as it's populated in here, when I come back and see if I have seen it before, then that's all I'm trying to do. And so what this will do is basically check any substring to see if it's a non-repeating character substring. That means it doesn't have any repeating characters in it at all. If it does have a repeating character, it'll hit this case and break out as false. If it doesn't, it'll loop through the whole string and it'll get here and it'll say true because every single value in here is unique. And I probably could use like a set maybe or something for this. But I'm just going to use a map. I probably could use a set though for this, but I'm just trying to, for the sake of time, I'm not going to go back and redo all that. So yeah, anyway, this looks pretty good. Usually what I would do at this point, if you're in an interview setting, some companies allow you to run the code you've written. Some companies don't. Some make you just talk through it. But what I'm going to do, since this isn't the most optimal solution, I'm not going to like walk through every step of the code. I'm just going to simply check that my code makes sense, and then I'm going to run it, and then I'm going to move on to the more optimal solution because I do want to repost this video and I don't want it to be 80 minutes long. So, anyway, so yeah, so length of the longest substring, starting out with this is 0. This is my answer. So the longest substring at this point is 0. Then I'm going to have a loop here as my starting index, a loop here with my ending index, which the end is either always equal to or greater than the start. So once I start at any point, I'm going to just keep iterating the end to basically, this basically is a way to find all the substrings inside of the string. And then when I get inside of the string, I'm going to use this other function that I made down here called is non-repeating character substring with the substring I currently have from nesting these loops, start and end. And I want to check, is it a non-repeating character substring? Is it one that I should consider as my longest substring? Yes, it is if it beats this if condition. And then here I say update my longest substring length to the max of the current substring length and end minus start, which that will give me my substring length basically. So and this might not be right because I'm looking at this end minus start if I think this needs to be end minus start plus 1, because if these are equal, then I would get 0. So yeah, I think this might need to be end minus start plus 1. Now I'm thinking about it. Or if it's 0, it needs to be 1. I don't know. I'm gonna try to run this and I'll fix any problems that I see. So yeah, so Leetcode allows you to run this, and we're gonna see what we're gonna get. I might not finish. Math max is not a function. Okay, so what is the JavaScript? Now I've forgotten what the math max is. Who knows what math max is in JavaScript? To find the max value between two values. Dang, I thought that was it. Math max. I thought it was math max. Is not a function. And I'm on JavaScript. I haven't done these problems in a couple weeks, so I don't know. I'm forgetting what the math max. I was sure that was it. I'm gonna look this up because I don't want to get stuck on this, but I thought it was math max in JavaScript, so I don't know. Okay. It's lowercase. That's what happens when you use a bunch of languages. You just, I don't know, you forget the syntax sometimes. All right, so got all of these wrong. Output is 2, and the output should be 3. So I might be off by 1 on all of these. Let me see. Yeah, looks like I'm off by 1 on all of these. Yep, so just like I thought. That's why I got stuck, and I was like, I think this should be like n minus start plus 1. So it's like an off by 1 issue. And this will happen when you're doing like interviews, or you're doing these, or if for some reason you need to do an algorithm like this in your job. You probably don't, but if for some reason you're doing some sort of algorithm, like off by 1 errors are common or so common thing that you look out for. So I'm going to run this. Yep, and I got all 3 cases. Just fixing that off by 1 error. And that's just because of the way my pointers are, my start and end pointers. It actually, in order to calculate the length, I need to add 1 to basically show the length from one pointer to the other. It's off by 1 error. It makes sense if you think about it. I don't want to go through and try to explain it, but yeah. So yeah. Anyway, that solution works, but like I said, it's not that optimal. And so what I'm going to do is Leetcode allows you to submit your answer to all of Leetcode and see how you stack up. If it even runs. So when you submit this, it's actually going to run it through. Here it ran it through the 3 test cases from over here. Example 1, 2, and 3 that we talked about at the start of the problem. And then what happens is when you hit this submit, when you hit run, it'll just run it against those 3 test cases. But when you hit submit, it's going to run it through like some really deep test cases. So you'll see if it works when I run it through all these crazy test cases. And see how long it's taking? The algorithm is really not that good. So yeah, and I'm just sitting here because the algorithm is really slow. So time limit exceeded. I expected this because my algorithm is really slow. And so let's talk about how slow the algorithm is, and then let's move on to the better solution. So why is this algorithm slow? So one thing, I'm going to close this down. One thing is we need to think about the time complexity of running this algorithm. So we know here that we're looping through our string once. And if you know what big O time complexity, like the measurement of time complexity, big O notation, and space complexity or space and time complexity, then you know that it's based on the size of your input and how your algorithm scales and performs based on the size of your input. So the size of our input is the length of this string S. And so I know based on the length of this string S, I'm looping through it once. And then for every time I loop through it, I loop through it again. I loop through the rest of the string again, basically. Well, almost the rest of the string again because I start at N. But if S is really long, then it's basically looping through the string again. And then even when I get down to here, this 9 repeating character substring, inside of here, I actually loop through part of the string, the substring, again. But I'm checking every substring. And so basically, in big O notation, you kind of round up for the worst case. So basically, because I'm basically nesting 3 loops that are tied to the length of S, and let's call the length of S N. Let's just call it N. It's just for the sake of this problem. Because I'm nesting 3 times, then it is into the 3rd power. Because for every time I loop, I exponentially loop again once, which will give me into the 2nd power. And then I also loop a 3rd time, which gives me into the 3rd power. So that means for every single length of this string, you multiply it to the 3rd power is how many operations that I have to do to solve this problem. So let's say that's fine when N or the length of the string is this, or the length of the string is this, or the length of this is short. So I can do this to the 3rd power. It's not that much for a computer. But what happens when S length equals the size of that string is 1,000,000 or something, or 1,000,000,000. Now I got to do 1,000,000,000 to the 3rd power operations. And so that's when you get stuff like time limit exceeded. And let's say there was database. In a real scenario, there may be database calls in here. There may be expensive operations that causes algorithm not to be performant. So the time complexity of this algorithm is big O of N to the 3rd power, which is not good at all. That would not pass an interview. And depending on the scenario, in a work scenario, that probably wouldn't be good enough for a work scenario. You might, if your input is small all the time, you can guarantee that you have a small input, maybe it doesn't matter. But if you can't guarantee that, then you would have some issues with your performance. And then what's the space complexity? Well, the space complexity is Only place I'm using space is where I'm using this map. The only place where I'm using space that is tied to the size of my input is where I'm using this map. And the most that I put in this map is, because I would always break out if I seen the character again, would be like the size of the whole alphabet or the size of the number of the number of characters in the string, whichever one is lower, basically. I know it's kind of hard to explain, but I would only at worst case, that's how big O notation works. At worst case, I may get a string that has all the letters of the alphabet in it. And so I'd have to basically I have to store every single alphabet letter in here in order for this algorithm to complete right here. So that's how much space I would use. And then I would always just erase this space every time this function returns. So that's what that is. I know this one is taking a little while, but now we're finally going to move on to the most optimal solution. Appreciate everybody sticking with me. And what I'm going to do, I'm going to erase all this stuff. And we're going to start over from almost scratch. I'm going to basically erase all of that. I'm going to keep this because I'm going to still need that. Matter of fact, I'm going to erase all that too. So you can see it from scratch, or whatever. So what's a better solution? I'm going to go back over to the problem. What's a better solution that we can do? So somebody mentioned it earlier, but the better solution, I wouldn't say this is something super intuitive. This would be something you would learn from doing problems like this and just getting more experience with programming. But there's a technique, an algorithm that you should know if you start to get into programming, or you start to getting, especially if you're interviewing, you have to do like Leetcode type problems or coding challenges and algorithms. There's a sliding window technique is what it's called. And I kind of had this concept of using 2 pointers where I had a start and an end pointer, but I was using it by doing these nested loops. Well, the sliding window technique, you're able to basically use a single loop and still keep track of these 2 pointers, start and end, and move them according to certain criteria, where you always have this little window where you're checking your substring and you're checking, okay, does it have repeating characters? Does it have repeating characters? Does it have repeating characters or not? As you loop through one time, instead of doing this nested loop where you're checking all these different substrings. And I know that may be confusing, but the sliding window technique is a common technique used to avoid nested loops, used to optimize problems where you need to check some subset of a string or subset of an array, where you need to look at it's called sliding window because you need to check certain things at certain windows of your total input, and you need to move the window, slide the window based on certain criteria in order to complete the problem. So let's hope I remember how to do this, because it took me so long to do that first problem. I might be rusty at how to do this, and I haven't coded in a while, so we'll see. But if I'm not ashamed to get help if I need the help. And I'm just trying to help you guys, I'm trying to help myself. So let's get into it. So like I said, what I'm trying to do is basically use this sliding window technique. And what that consists of is basically, instead of setting up loops to get my start and end pointer, I'm going to go ahead and just set both of my start and end pointers here at the top at 0. And this is going to start making more sense as I write this out. And then I'm also going to have my answer variable here that I can store my answer in. So longest substring length. It's going to start at 0 because we don't know anything yet. And I always like to just go ahead and return my answer just so I don't forget at the end and just leave space in between. And so basically now I want to loop one time through my input. And so how I could do that, I could do a for loop, but what I'm going to do is a little, I wouldn't say trickery, but another technique where I use a while loop, where I'm going to say, as long as my end is always going to be after my start, as long as my end pointer is less than the length, because it can't be equal to the length, it's got to be less than the length, because it's a 0-based index. While it's less than the length of the string, keep looping through here. Keep looping through this string. And as I move my end pointer, I will basically be kind of looping through my string in that way. And what I also want to set up is this time I want to set up a set, a JavaScript set. And what a set is, a set can hold unique values versus a hash map or a map. A set will hold unique values in it. So you can't put duplicate values in it. You can only store unique values in it. And so how this helps us in our problem, because the whole problem is about finding the longest substring without repeating characters. So I can basically use a set to denote whether I've seen something before or not. And I can also remove things from the set if I'm sliding my window down. And so what I want to do in this solution is basically open up a window where I have a start and end pointer, and I want to move the end pointer and add things to my set, my scene set. And as I add things to it, I basically want to say if I haven't seen a repeat in it, I want to say this is the longest substring I've ever seen. I want to store that value. If I do find a repeating character, then I want to move the start of my window up to the point of not having any repeating characters in my window anymore. And then I want to basically start over and move the end again until I find a repeating character. Then I want to move my start over till I don't have any repeating characters anymore. And basically by just doing that all the way through the string, I know it can be a little confusing till you can wrap your mind around it, but by doing that all the way through the string, and if I keep on saving the longest range that I've seen, then by the end of looping one time, I will have the longest string that doesn't have repeating characters. Because remember, every time I see a repeating character, I move the window up and I remove, and as I'm moving the start of the window up, I'm going to remove the duplicated character out of the start of the window. So I know this is confusing. This is a medium problem, so it's not supposed to be easy to understand. But hopefully, as I code this, it'll make more sense to you guys. And at first, I thought this was an easy one, but now that I'm trying to explain it to y'all, I kind of understand like why Leetcode calls this a hard one, because it's not easy to explain. And yeah, I know people leaving comments. I really appreciate it. I'm trying to keep up with it, but I'm also trying to think and explain at the same time too. So I really appreciate y'all leaving comments too, because it helps everybody. So please keep doing that as well. But anyway, I'm going to keep going. So I hope that kind of made sense what I'm trying to do, and hopefully it will make more sense as I code this through. So the problem's up here if you haven't seen it yet. I've made a start pointer and an end pointer. I made this longest substring link to keep track of the longest one I've ever seen, because that's what the question is asking for. I have a set to keep track of things that I've seen before, and I'm going to keep manipulating this set. And here I've set up a loop to basically say if end is less than the string length, keep this loop going. And I'm going to keep moving end until I get to the end of this, and that's when I'll break out of this and just return my longest substring length. So what do I need to do inside this while loop though? So in this while loop, basically what I want to do is I want to say if I haven't, so scene is my my set, right? So I want to basically say if I haven't seen, I'm going to look at S is my string, and I'm going to look at the item or the string, the object or whatever, the thing that is in S at, what the hell? The string that is, the thing that is in S at end, which is, I don't want y'all to get confused by this, but like the character that is the like in character. That's what it is. It's basically, this is how you pick out the character that you want to look at out of the string. But I'm not going to save that there because that wastes space, and it makes my algorithm slower. So basically I'm going to say, have I seen this character at the end, at my end pointer? Have I seen that yet? If I have seen that yet, what do I want to do? So, or if I haven't seen it yet, sorry. If I haven't seen it yet, what do I want to do? Well, what I want to do is basically add it to the scene list, my set, because I haven't seen it. Sets are unique values. If I haven't seen it, and I can add this new unique value to my set. And so now I can just move on. I can basically iterate in to get closer to the end of my string because I haven't seen this character yet. I'm going to add it here so I can check if I've seen it before or later. And I just need to expand my window. So start will stay the same. It will stay at 0. And end will move to 1. It will move to 1 or 2 or 3 or whatever it is. So now my window is expanding, checking my substrings. My window is expanding. I haven't seen this string before, and my window is expanding. And so in this case, I actually want to, in all cases, I want to update my substring length like I did in my previous solution. Let me make sure I don't mess up this again. Math max. And I want to say, I want to I'll either want the longest substring length if it's higher, or I want that end minus start. Whichever, so math max will take whichever value is higher. Is it my current value higher, or is end minus start? That is the size of my window. And I might have to add 1 to this again. I can't remember. But I'm just going to leave it like this for now. I might have an off by 1 error here, but I'm going to leave it right there for now. So end minus start, and so that will give me that. But I also am missing another case here. So what happens if I have seen this before in here? So in that case, that means I'm running into a duplicate. And so in that case, I need to move the start of my window up because the duplicate is somewhere at the start of my window. Because if I've been adding stuff to adding to the end and adding stuff to my scene list, and I haven't run into a duplicate yet, then once I do hit a duplicate, it's probably at the start. Or it might not be. No, that's not true. It might not be at the start. It might be somewhere in the middle. But basically, I need to move my starting window up until I find where that duplicate is. I'm sorry. That was wrong. But the last thing I said was right. I need to move my starting window. So let's say, let me try to explain this using an example. So here, if you see, I have A and A that ends up being a duplicate. In my thing, I'm going to start with a sliding window. I'm going to start both of my pointers at A. And then I'm going to say, is A in my scene list? No. So I'm going to move my end pointer to B. So my start is at A. My end is at B. Is B a duplicate? No. So I'm going to move my end pointer to C. So my start is at A now and my end is at C. Is C a duplicate? No. So I'm going to add it to my list of things I've seen. But my window is 3 things long. And as I said before, now I know at least my substring length is 3 because that's what I'm calculating here at the bottom here. But then it becomes interesting when I'm here and I run into A. Have I seen A before? Yes, I've seen A before. So what I need to do now is move the start of my window up into the point where I basically don't have any duplicates again. And so what that does is when I'm going to take out this duplicate, then when I check A again, it won't be a duplicate anymore because I'm going to remove this out of my scene list at the same time as I move my start pointer up. So it's not even in my window anymore. So it doesn't need to be in my scene list anymore because it's not in my window anymore. And so now it's still 3, but now I've moved along, and then I check B. But when I check B, it's still in my scene list. So then I need to move my start pointer up to here again so then I can add B in. So, and then as I'm going through this whole thing, if you see I have a range and I'm calculating the length of this range, and whichever range I get that's the longest, it's which one I need to return as the answer to my problem. I know that's a lot, but it's a medium problem, and yeah, it's just maybe some people are getting it. Hopefully you are. And if not, then please go practice this problem on your own, and hopefully I'm helping you guys get into it. Somebody said, I know I'm diverting, but somebody said I sound like Kanye. That's crazy. That's weird, man. I don't think so, but appreciate it or not appreciate it or whatever. But anyway, so where was I? So yeah. So anyway, when I get here, if I have seen this in my scene array, or sorry, my scene set, then what I need to do, what did I say I need to do? I need to basically remove this from I'm trying to think, do I need to remove the start or the end? Yeah, you know what? I need to remove the start. And then I need to move my window up from the start, like I said. So I will delete the first item in here, and basically as I loop through here, I'm gonna keep on deleting starts until I get to the point where I get to something I haven't seen before because I've deleted it out. And it's kind of weird, but it really makes sense when you kind of wrap your head around it and run it and debug it. It'll really make sense to you. But I know it's kind of hard to understand, especially if you don't do these problems a lot, because like I said, if you're going to go look at some more easy problems, I've done those on my channels and accounts. But yeah, this is a medium one we're trying to do. So please, just let me know if you have any questions and I'll try to answer, but I'm going to try to get through this problem the best way I can. So anyway, yeah, so I get to the end and I've done this. And I think at this point, this is all that I need to do. Now that I'm looking at it, I think this is right. So set up a start and end pointer. I set up my kind of return variable. I set up this scene set that I'm going to keep mutating. I'm going to keep adding stuff to it and taking stuff away. I'm going to loop through this while end is less than the length of the string because it's impossible to go beyond that. So if I haven't seen something in my set, which is a set is a unique values. It can only have unique values in it. Then add it to the set and move my end pointer, expand my range basically. Else, if I have seen it in the set, then that means I can't move my end pointer until I delete all. So I move my start pointer up to the point where there isn't a duplicate anymore. And so once I've done that, I'm going to keep looping through here and I'm going to go into this condition and move the start of the window up into the point where I can finally get back into this condition again and move my end pointer. And the whole time I'm doing these operations and I'm looping through over and over, I'm checking to see end minus start, and I'm going to keep saving the longest substring that I've ever seen. And what mathmax does, instead of doing like an if condition to say, if this is longer than that, then set this, math does that for you. It basically says, is this one longer than this one? Then set it to equal to this. So I'm basically just constantly updating the longest substring I've seen. So yeah, this looks like it works. So in the interview scenario, some companies allow you to run code like this. Some companies don't. What I always advise to do in either way, and if you have enough time, is to run through this kind of like, not with pencil and paper, but kind of in that spirit of pencil and paper. Keep track of the variables in your mind, or like type them out here and run through the code line by line, like logically, before you actually run it and explain it to the interviewer. And this is JavaScript for people who's asking what language this is. And so I know I have a start variable. First I have S. Tripping. So whatever S is, that's what's getting passed into the function. Then I have an N, which is my start and end pointers. I have a longest, which I'm gonna copy this because I don't feel like typing that over again. I have that. Then I have scene, which is basically a set, and it's not an array, but it's like a set of unique values. But I'm gonna visualize it as an array here. And that's all the variables I have here. So just start with a sample problem. I don't want to start with something too long. I'm gonna do this one since it's not too long. Bam. So it starts with that. So let's run through the code. The start is 0, end is 0. So let's populate that in our variables up here. Local longest substring length is 0. And the reason I'm doing is the interview might ask you to do this, and you might not even be able to run your code. Like, some interviewers don't let you run your code automatically. They make you walk through it like this. So this is something you might want to get good at doing if you're going to be interviewing with problems like this. If you're not, then you can just run it. If you're in real life, if you're working your job, or you're working on a side project, or you're working at a professional company, And of course, you can just run the code and just debug it and try stuff out. But, you know, it's good to know how to do this as well, just to really understand the kind of code that you're writing. So anyway, so yeah, I'm going to do it the way, like somebody said, the interview would go. And a lot of times the interview, they don't care so much about you always getting the perfect answer running in code. They want to know your thought process. They want to know that you can read through code like a computer can in your mind. So it just sounds kind of crazy, but yeah, that's what they want to see. So and I that's what I want to see when I'm interviewing people. I've interviewed a ton of people with problems like this. So anyway, where was I? Yeah, so I got to this point. Then it's a new set, so I've already initialized the set here. So while n is less than string length is 6. So end is definitely less than string length, whatever. And so it has seen is s at n, which is p. Is that in my scene array? No, it's not. And that basically I'm saying, is it not in there? And so I'm going to add it to my scene array. So I'm going to add p to my scene array. And then I'm going to increment n. So I'm going to make n 1. So now my sliding window is from 0 to 1. And then here I'm going to say longest substring n minus start, which that will be 1 minus 0, which will give me 1. So I've already updated my answer already in this loop. But I'm going to come back up to the top of the loop again. Is n still less than string length? Yeah, n is only 1. So it's less than the length of this string. Has the string at the character at end, at the end of my sliding window, has it been seen yet? No. W is the next character. It has not been seen yet. So I'm going to add it to my scene array, or scene set, I'm sorry. And then I'm going to increment end again. So my sliding window now is this instead of this, because it's from 0 to 2. So from 0 to 2 is this. And so now I'm going to update my longest substring length again. 2 minus 0 equals 2. So now it's going to be 2. And I'm going to start this loop over again. We already know the answer to the first question. Has W been seen in here? Yes. W is already in my scene list. So I'm going to go into this condition next, where I'm going to delete my starting. I'm going to delete the item in my scene list from the start endpoint. What's the start at? It's at 0, which that will make it P. So basically, I'm going to delete P out of my scene set. And then I'm going to also increment start to 1. So now my sliding window has moved where it's 1 to 2. 1 to 2. Now my sliding window is completely different than it was before. And then I'm going to say, I'm going to come back in this loop again. Oh, no, I'm going to do the substring thing again. The sliding window is still, this length is higher than n minus start. So I'm going to keep this value. If you see what I mean, math max, I'm going to take which is the highest. Is n minus start higher than the current longest substring length I have? No, so I'm going to keep that value. Then I'm going to come back in here again. I'm going to say has, now I'm on 2, and 2 is W. I'm going to say, has W been seen? Yes, it has. So I'm going to go into this case, and I'm going to delete W, or sorry, the start, which is, let me see, which is 1. Yes, I'm going to delete W out of here. And then I'm going to increment, like I said, I'm going to increment start to 2. And so now I'm at 2, 2. Now my sliding window is literally just W. So I basically like skipped all the duplicates, and now I'm starting over completely again at a new space. And so now I go in here, has W been seen? So now it hasn't been seen, so I'm going to basically put it back in here again. And then I'm going to increment in. I notice it's kind of dragging, but this is just how it goes. And then I'm going to, I already know that I don't have to update this again because it's only 2 minus 1, or 3 minus 2, which is 1. So it's not greater than 2. And then I'm going to come in my loop again. I'm going to say, has it seen K? No, K is going to get added in there. I'm going to increase my N. So I'm going to start just running through this. And so now my sliding window is here to 4. And then I'm going to say, have I seen E? No, I haven't seen E. Move up the sliding window. And so now 5 minus 2, when I get down to this line, 5 minus 2 equals 3, which is greater than my current substring length. So this is going to end up updating this to 3. And so then I'm going to loop back again. And then this is going to be on 5, which 5 is 0, 1, 2, 3, 4, 5. So that means my sliding window is from 2 to 5. Have I seen W? Yes, I've seen W. So I'm going to end up deleting W out of here and incrementing my start. 5 minus 3 is 2. And basically, I'm not going to finish the rest of this because basically from the rest of this, it's not possible from index 3 to 2 to get anything higher than 3. So I basically could kind of end the problem at this point. I really could have a check down here to say, like, if the rest of my string from start to end is less than longest substring length, then I don't even need to check the rest of the substrings. But I actually never seen anybody do that before, but that's a good observation that I just made in this problem. I've never seen anybody answer the problem with that part of it, but maybe that's the most optimal solution, I think, because there is a more optimal solution than this as well. But yeah, so yeah, I think that from that I've got my answer, which is 3. And so I'm not gonna go through the rest of these, but basically I've gotten the answer, and I would return it here because this would never change for the rest of the problem because there's nothing going to be longer than this possibly. And so then I return this. And yeah, so an interviewer would probably accept that because you're explaining them that you don't need to go through the rest of it. They'd probably stop you, honestly. They'd be like, yeah, I get where you're going with this. I know I would. So yeah, so with that, once I've done that, then if I'm able to run it in the interview, or especially if I'm working on my own in a real life scenario and I'm doing this for whatever reason I'd be doing this for, I would run this. So I'm going to try to run this to see if I got it right on the first try without even making any mistakes. So yeah, case 1, I was looking for 3. This was the case that I actually ran through. If you remember, I just ran through that manually. I got 3. And then this was our second test case from over here. And so if you remember from last time when I actually hit submit and ran it against all Leetcode submissions, I got a timeout error because of the algorithm not being very performant. It was big O of n to the third power. Big O of n to the third power time complexity. But what is this in time complexity? So as you see here, I don't have a bunch of nested loops like I did before. It's very much simpler algorithm. And I really only have one loop in here. The only important distinction to make is because I'm using this sliding window technique, and I'm using 2 pointers, I may look at every single, even though I'm looping one time, kind of like I have one loop, I may actually look at every single item in this list twice, because I may have a string where I have to keep moving the end pointer and move the start pointer all the way up to the end. So I may end up looking at everything twice, but in big O notation, if you have so that would be like 2 times n. So it's not exponential, it's 2 times n. I would look at everything twice, but I wouldn't exponentially, I wouldn't just be looping through, I wouldn't loop again every time I loop one item, or every time I come to one item. And so that would reduce in big O complexity down to big O of n instead of big O to 2n. And big O of 2n isn't bad because it just reduces down to big O of n. So the runtime complexity of the solution is big O of n, or big O of 2n technically, and it would reduce down to big O of n, because the two is kind of like if n is equal a billion, it would be like 2 billion. I mean, it's bad still, but it's not as bad as n squared, like a billion times a billion. It's just a billion times 2. There's a big difference. And so that's why big O notation works like that. And then the space is the same as it was before, because I'm still using this scene set thing. So it's kind of like, this one's like a more of a complicated space one, because it's actually like min of n or m, whichever one is smaller, where n is, say n is the size of the string itself, and then like m is the size of the alphabet. So like so let's say this string just consisted of every letter of the alphabet, then I would have to basically like populate this set with every item in the alphabet. But if it's less than that, then it would just be the size of n. If in the worst case that n was all unique characters. I know that's kind of hard to explain, but basically just like I use this max thing here to find the max between these two values, in this big O space notation, I'm finding the min between these two values. So where n is the, well, I'm not gonna type all that crap out, but anyway, hopefully you guys understand. Yeah, so that's, oh yeah, I need to run this. So I gave you guys the complexity. So now I hopefully shouldn't get a timeout exceeded, or time exceeded on Leetcode, because this algorithm is much more performant. I'm gonna make sure if I can take any variables out of here that would slow down my runtime. I don't think so. So I'm gonna submit it to Leetcode, and we're gonna see what we're gonna get. That ran way faster, because remember last time it sat there and just spin and spin, and then it eventually just told me it timed out. So I beat 67% in runtime complexity. I beat 60% of everybody else on Leetcode. If you believe these values, some people tell me not to believe the values. I believe them. I don't know. I mean, whatever. I've gotten some really low ones. I got really high ones. It just depends. And then I beat 58% in memory, which is the space that I was talking about, which this makes sense because it would be 50%, because I'm pretty sure everybody's doing like this almost exactly the same thing. And this was almost pretty close too. So yeah, I got this answer correct, and it ran performantly. Is there a more optimal way to do this problem? Yes, because my problem actually at worst case will look at my solution actually will worst case look at every solution twice. It is possible to do this where you only look at every letter twice, or every item twice. It is possible to do this where you only look at every item once. I don't understand how to do that, but there is a third solution in Leetcode of like how to do that. But in the interview scenario, you'll probably be fine with this answer, and with some sort of like, and just even knowing there's a better answer or something. But to me, I think this would be far to go. If I was interviewing somebody, this would be as far as I would go. So anyway, yeah, I appreciate y'all watching. I'm on TikTok. I'm on Instagram, YouTube. Twitch, Twitter, Facebook. I'm on everything, streaming live. Do these tech interviews are trash. And so yeah, I hope this is helpful to y'all. Like, good luck with whatever your endeavors are. You know, follow the channels, whatever you're watching on, or you can find me in another channel. I'm probably there too. And I'll be doing these at least once a week. I'm gonna try to move up to twice a week. Plus I'll post a bunch of other content as well, like funny stuff and informative stuff about programming. And so yeah, appreciate y'all joining, man. Appreciate all the comments. I'm sorry I didn't get to read everything. Y'all know how it is trying to do these problems. I can't be sitting there reading all these comments, trying to focus on this stuff, or I'll just break down and just won't be able to do it. But this helps me, man. This really gets me like really comfortable with doing these, because I got all y'all watching me do it, and so it's like I'm just like kind of like antsy or whatever. So then if I ever do get into an interview, it's like, oh, I only got one person watching me. So this is a lot easier. It's still the stress of them controlling your future and all that crap. But you get what I mean. It helps in some form. So anyway, I'm about to sign off. Appreciate y'all. See y'all in the next video.